Hi guys, welcome to my YouTube channel. Today I will going to again continue an tutorial on another data science project known as Delhi House Price Prediction. So first of all we will going to overview it. For the Delhi House Prediction project focuses on predicting the prices value in various localities like Gurugram or Rohini or and some another ones. The primary objective of is to develop a predictive model that can accurately estimate the prices of houses based on several key features present in the dataset. The dataset of Kaggle contains the information of factors such as house area, number of bedrooms, locality, and more. By analyzing this feature, you can get an idea of. So, for the data dictionary, we have the rows as 120, 1259 and row column as 11, and it has the dictionary as area of houses in square feet, BHK, number of room, bathroom, furnishing, condition, locality, parking, price and status, transaction and type, and per square feet. Later we will going to add in another column which will have the area per yard from this by dividing it by 365, wait a second, by 7, sorry. Okay, from this project we can get an impact as in a twofold. Firstly, it addresses the need for accurate house price prediction in the dynamic real estate market of India's unitarity as Delhi. Potential buyers can utilize the model's prediction to make the informed decision when purchasing a house. Sellers, on the other hand, can gain insight into fair pricing strategy for their properties. And second, through the EDA, significant insights have been uncovered. The analysis received the house prices influenced by factors such as the area, number of bath bathrooms, bedrooms, and locations. Localities like there are Punjabi Bagh, Lajat, Rajpat Nagar, Vasant Kunj, and there are some of the properties which have the high end areas. The preferences for new builder floor properties indicates a demand for customization independence in terms of machine learning. The project employs the Regression model as the decision tree, reinforces regression, and with the impressive accuracy as 18.4.98, and in the conclusion it will going to give the insights of various amount of offering both buyer and sellers a reliable tool for house pricing and utilization of underscore commitment to accuracy and efficiency in predicting house prices and contributing to informed decision making in the real estate domain. So let's go to our next part in which we will going to make a data set. So guys, we have go to our make dataset file which we have taken in the source folder into another folder called data, which will going to create an data of it. So for the first of all we have taken the modules which are necessary for the data pre-processing as pandas, numpy, operating system, and scampy for statistics. Okay, so for that we have do the take the data set from the lower part of it, like as we have defined the class as raw data path as operating system path dot join data raw magic bricks. It has, and the process data will be go as the OS path join data interim clean data CSV. Okay, and then we will going to load the data as the DF way, like the raw of it right here, and predict, give it the first row of data, then the statistic summary of it, and the number of null values, and then we will going to do the clean data part and the remove outliers, and then numeric def clean removing outliers using z-score method, as it will going to take the clean data dot select data types include np number dot columns, and z score is equal to np apps stats z score and bracket inside dev clean and now numerical columns and closing the brackets. Then the we will going to take the z score as less than 3 and dot all access as 1. Okay, then it we will going to print all of the part of the other null value after cleaning of them, data types of each column, count of unique values after cleaning, and count of each unique value in each column after cleaning, and then we will going to group the localities. Then we will going to divide the area part by 9 for the area yards part, and then we will go to our grouping insights, as it will going to take the count the unique counts by locality as the div clean group by locality dot and unique, and print it. Then we will going to print it, and then it will going to take the number of values in each of the part, and then finally summary of it, and it will going to save it. Okay, and for the locality part we have defined the Rohini as Rohini sector, Dwarka as Dwarka sector, Sahadra as Sahadra in the capital first, and Vasant as Vasant Kunj, Pasim as Pasim Bihar, Alakhand, Vasundhara, Vasundhara Enclave, and then Punjabi Bagh, then Kalkaji, Rajpath Nagar, and if any other location comes, then it will going to return the other. Okay, for the, and we have taken the all of the localities in the lower format to avoid the case sensitivity issue in the Python which we used to get. Okay, so let's run it for our reference how it is going to work. So guys, we can see right here it has given the output as the first row of the raw data, as we can see the area A as the normal way in the square feet, and BHK numbers as 3, 2, 2, 2, 1 in different way, and bathroom as 2, furnishing as a semi and furnace way, and status is ready to move, transaction type as the section as a new property resale way, and type as the builder floor apartment, and the square feet as null value or 6.77 way. Okay, first, and then the static summary, it has given the count as the same, like bathroom and parking and pricing has the different value, like it has suggested some amount of the null values, and then the mean as the 146 point s, and then this way, and those are the three ones, then the two are bathroom and similar with the other parts, and standard deviation of them, and the minimum part, and 25% of the values, and then the 50% and 75 and max. Then it has taken the null value counts, like we have above seen, it has shown, it has given the same value as, and then after outlier removing and after cleaning, it has go to 0. Then it has, we have taken the data types of each of them, as it has given the float, phk int, and bathroom as this, furnishing, locality, and other type of data type you can see right here, and in total it has given the data type as object. Okay, then it has taken the unique values. After we have taken the count of it, it has given the 258 5 ph 553 293 6 2 then 222 and 230, and then it has goes to count each unique part values, and it has counted numerous way, and then the BHK values as number of BHKs, how many are there, it has also given its numbers. Okay, and then bathroom values as it has also given it, like for the 2 it has 300 383 and 83, and 3 as the 242 number of bathrooms, and 118 and 96, and where I have forgotten, like it has also given the so much part. Like you can see right here, it has given the transaction value counts, status value counts, price value counts, and everything that you are needed to be having, like JR designer flow at the ONE sector, like different positions places. And at last, for after the removal of it, we have taken the its summary as this. It has taken the data, and then it has stopped it. So after that, we will go to our EDA part. So guys, we have came to our EDA part, as we will going to use the basic models which we'll going to use right here: pandas, numpy, matplot, pyplot, and then the seaborn. And we have taken the data set from the data folder. It's like it has right here the clean data right here, and we have, for the checking, we have taken the sample of it, first 5 rows, and it has shown the data set as it has the data like we have seen the before. Okay, then we have started the area part by the house area of houses by using the histograph through the C1 module, as we have defined the X as the def area yard, KDA is equal to true, and bins as 50, and then it has, we have given the areas in yards title to it. Okay, then for the trend it has goes for the most of them are in the 82 and 200 yards. Like it has at the peak it has been 170 of more than 70 of them. For the detailed one analysis part, you can see my this part which I have by pausing the video. Okay, so I will go to next part of it as the PHK parts of this, how it has the count, and it we have taken the counter plot right here, and the x as PHK and data is equal to df and title as this, and then we have taken the BHK part as it has taken the most of the houses has the 3 bedrooms as more than 350 values, and then the 2 BHK and the 4 and then 1 and then 5, like we have seen in the data pre-processing part before. And for the detailed analysis you can read this right here. Okay, so we go to our next part as bathroom counts. Similarly, like we have done for the BHK, we have taken the X as bathroom and data as TF and give it a title as bathroom. Then it has most of, so the in the data most of the houses has over around 382 bathrooms, then the less than 250 as the 3 and then 1 more than 100 and then around 84s and less than 20 around 25 as 5. For the detailed it you can see right part of it and check it my own report in which I will going to give you up in the source code or right here by pausing the video. Okay, check it. Furnishing count, we have count plot access the furnishing data as df, and then this most of them are 500 around semi furniture, then the furnished furnace, and then the lesser version. Then for the more analysis I have written right here. Okay, then we have the main part of as the localities. Right here we have taken the counter plot method x equal to locality data as is equal to tf and set title as locality, and then the plot x ticks as rotations equal to 90, and it has the 9 values, and it has so the number of it as Rohini, Lajpat Nagar, Dwarka, and Santkunj, Santkunj, Sahadra, Pasim Vihar, and Vasundhara Enclave, Punjabi Bagh, and Khala Kachi. Like right here, it has given it data. Most of them are outside of that places range, so it has the most of the others are right there. So for the overall trend, you can check the analysis right here by pausing the video. Like others have the different types and lower, as you can see. It is generally 100 less than, and Rajpat Nagar and Rohini and application you can read from here. And then we have go to our parking section. In this we have again take the counterplot method and give it in a title as this, and it has given the data of it, as most of them are having the one parking space around 590 something, and then the two around two about 200 just, and then the around less than 50, and then 4 and 5 less, and then 10 very less. Okay, so much. And for the detailed analysis, you can check out my this analysis written right here. Okay, so we go to our next part, status, as it has the X status, data is equal to df, set title, status of property, then it has given the ready to move condition, most of them, which is the very good part for the buyer and sellers, and for the investors they can check right here also. Okay, and for the detailed analysis you can see this analysis that I have written for you guys by pausing the video. Okay, and then we have taken the transaction type as the again count plot, and by transaction type, and it has so the more than the part as the 350 as the new property in the Delhi, and for the resale it has been more than the 500 properties. Okay, and then you can check out the main analysis of it in the detail right here. Okay, so for the house type we have taken the counter plot type comma data type types of houses. Okay, then it has most of are the builder floors like around the 500, and then the apartment around 380, and then we have go to our analysis of, we have given the analysis of it in the detail format. Okay, and then we have go to our comparison parts, like how the area and different factors like locality like features had been affecting the price. So for that we have taken the scatter plot and use the x yards and then the price, and take the data set and define the areas. For the prices it has shows the like pricing as that, it has been showing the some amount of like locality like is but some as having the very good pricing, and basically the trend is going with the increasing yards of it normally. Okay, for the detailed analysis of this scatter plot you can pause the video and check it this analysis, or if you are doesn't have want to check it through my git repo, you can go right there. I will going to give that in my description box. Then we have go to our price and bhk affecting. Right here we have taken the box plot method. For the first ones it has the lesser margin and lower value than the two ones has the more, and then the 3 and 4 has the most of them part, as it has the covering the higher margins price rates, and then the 5s which are rarely supportive, rarely buy it, like most of them are business like purposes. Okay, then for the detailed analysis of it you can check out my this part, or if you are bit lazy then you can check my reports from the git part. Okay, that I have created, and okay, then we have go to our bathroom or content price. Similar way we have got the bathroom part, like we have gained the upper part. And similar way you can check its analysis right here. And then the parking, as and its price, we have taken the parking price and its title as parking versus price, and for the most of them are around 1, like you can see right here, and then the 2, and then the 3 has a more pricing, and then 4 with less, and then 5, and then 10. Okay, then for the detailed analysis of it, you can check out this full analysis that I have written for you all guys. Okay, then we have go to our next part as the locality and its price. It has the scatter plot as the locality and prices, and we have taken the scatter plot, not scatter plot, box plot method. Sorry, right here you can see it how it has others has the most of the values, and then Rohini and Rajput Nagar and Dwarka and various amount of, you can see the how margin and its shadow and rated values. For the detailed part you can check out this. Okay, then we have go to our furnishing. We have taken again the box plot for the furnishing and price, and we have taken the its graph versus, and then we have got it its result as the semi features are more of them with the okay larger margin than any other ones, and then the unfurnished ones has the lesser value, and then furnished one. For the full analysis you can check again right here, and then we have go to our status and prices. Similar way like we have done it by this box plot method. Okay, then we have got the most of them as we have seen before in the data pre-processing part, as most of the value in the ready to move and then almost ready part, and then we have taken its detailed analysis, like you can check out after this video. Okay, and then the transaction type as X box plot x equal to transaction and price, and then transaction and price type as it has the most of them has the resale part, and then the new property has the price. Okay, then its analysis you can check out again. Then the property types, as we have taken again the type and pricing of it, and it most, like you can see the trend, most of the builder floor has the higher price than the apartments by the higher margins, and then you can check out the property type versus box plot analysis part, which I have written for you all guys. And at conclusion of all of this, and then it is ended. Okay, so we will go to our feature engineering part then we will go to execute the correlation, heat map, and then the models of it. Okay, check it. So let's end it. So we go to our next part as feature engineering, and we have imported the model as pandas, skyline processing, by the label encoder and taking another model part as minimum max scalar. Okay, then we have load the data set, and last time before completing its process, and we have taken the LE as label encoder, and we have taken the main part as the furnishing locality, status, transaction and type for the further and model building, as it will going to get easier, as these part as a semi furniture and localities as Rohini and Dwarka will going to lower its speed, so and make it harder to for the models to operate. So we go to our how it will going to work. It will going to take the for loop in the columns as label columns, def column as the left fit transform, def column, right it, and print it in the unique format, and then we have go to normalizes normalization at the maximum and scalar part as the area, price, square per square feet and area yards. Okay, and then the we will going to transform it, and at last we will going to save the file to it final data set. Okay, like I have done it before for before all of this for avoiding any indifference, like right here it has become a last data set. Okay, and then we go to our next part before the model making and evaluation of it. We have taken the models as the Seaborn, Matplot, PyPlot, Pandas, rating system, and then we have defined the function as the plot correlation heat map, and then we have taken the data path inside of it and save path as none and figure size at 10x8, and then you can read it, and then we have taken the loaded data set and then calculate the correlation matrix for the numeric values of it as the correlation depth Volre numerical value true, only true, and then the fish size as the fish size, and then we have inputted it's the heat map as in that cool format, annotation true, and the goal and the line width as 0.5, and then we will going to give its title as the feature correlation heat map, and then at last we have saved it in the by making a path directory in the result, not result, in the right here. Okay, as then we have given the confirmation method, and then we have to the showing part as, and we will going to save it. For avoiding any time waste, I will go to just the heat map. Okay, for in your own right here you can see is the its full heat map. Right here it has shows the values and how it has been affecting the data set. Okay, which is which describes that it is in a very okay and good type of a data set. Okay, so we have go to our last part as the model building. Okay, so for this we have taken the models as the operating system, pandas, numpy, matplotlib, and seaborn and joblab, and then the data science models as the model selection as a train split method, and then the matrix mean absolute error, mean squared error, and R2 score, and then the standard scalar reprocessing, and then the linear, then the models as XBoost, random forest, decision tree researcher, Regit and lasso. Okay, then we have taken the models as the model saving. We have taken again the data path as again data set. Then we will going to give another splitting part, as it will going to have the test models as right here you can see, and then the model save, it will going to save it in the models files, and then we have given the split and model creating these both of directories. Okay, and then we have go to our main part of it, as we have load the data set from the data path, and then we have defined the target and its features, as the target column is equal to price, which is the main motive of this project, and then we have taken the numerical features as the all of the column as BHK, bathroom, parking, square feet, area yards, and area. And then we have go to our next part as the X df numerical values, and then the Y as target column. Then we have created the X train and test split format. We have taken the X train, X test, Y train, and Y test, and then we have defined the X test to size as 0.2 and random state as 42, and give it the X and Y data frame, and then we have split them into the different files. If it has been not saved right here, it if it was not saved, then it will going to create it like right here you can see by the code. It will going to create it by its name right here. I have defined it, and if it has been not created, then it will going to saving the test split to data models dot, and then it will going to save it, which will going to take a little bit time, but it will be worth it for your futures self if you have been wanting to create again. And then we have given the scale features part. We have taken the X scaled as it transform X train, and then the test part similarly. Okay, then we have taken the all of the models that we have taken before, model dictionary format. Right here I have taken the right lasso and decision tree reservation as the random tree 42, state as 42 needed, random forest one as n estimator is equal to 100, and random state as this, and then the X B regressor as the n estimator 100%, 100, learning rate as 0.1, and random state at 42. Okay, then we have go to our last function, as it will going to do it last part of the evaluation. Right here we have created the training of it before, and it has started the evaluation. Okay, then we have taken the name, module, X train, Y train, X test, and Y test, different type of stuff. Like, then we have fitted in the X train, Y train, predict the test, predict the train method. Then we have saved the train modules in the module file name, the dot path, join model save path as the in the F string, and the name dot lower, then the lower dot pickle. We write right here wait a second, where it was, right, you can see in the models form. Okay, then we have dump it right there and print the that model has been saved to there by the file name we have taken. Okay, then we have go to our main part as the test. We will going to conduct as the mean accuracy test, error test, it sorry, absolute error test, sorry, y test, predicts test, and then the we have take the root mean squared error test as by using the numpy square mean squared error and then the y, and we did test and like we have done and with the similar in the R2 method. Like right here we have done the test part for the test part and then the again for the train part we have done it. Okay, then we have going to take the display all of this in the terminal, like if you are wanting to, like it has given the test of train and test performance right here. I am deciding it, and then we have go to our last part as the comparison tables, which will require us to get the so much amount of right here. Like I have taken all of its images, like how it will going to work and its detailed result and its prediction of how it was done it, like right here. Then I have go to take its scatter plot versus actual versus predicted. We're going to go to figure part as 6,4, plot the scatter as this, then the y plot minimum value, then y test minimum maximum value, and then again the y minimum and y maximum value in the opposite format and the r, and it will going to do the x and y label as the x and y as the predicted, and it will going to give the prediction versus actual value in the scatter format of various type of models we have given it, and it will going to give the result in the image format, like it has the scatter, and it will going to make it stated directory and close it, and then it will going to end. And similar way we have taken the distribution plot graphs for it and save it again. And if and for the some part like Regit and lasso, we have needed to change the some part as the name and model and x train and y train test will needed to be right there scaled, else they are already fine. So we will going to check how all of it's like graph of it, decision tree, and the scatter. Like lasso, it has been doesn't work on it, so it has been showing right that on this data set, and then the random ones and project and similar way like XBoost, and it will going to appear. So let's go to our last part. It has given the accuracy as this, which is the relatively good for the test ones. Right here we can see accuracy, and then lassos are least accuracy, least worked right here on this data set. Then the rigid ones, and then random forest and exposed. And for the actual and predicted value, you can check out these CSV files of them, like it has given it an example right here. Right here you can see its number of values had been given here. It has given the similarly with the other types. So for that project you can go to my own Git repo after this video ends and tell me how this video was created for and help you in making the further future YouTube tutorials like these kind of. And if you guys wanted an tutorial on AI based website, then I can also create it for by using this data size. Okay, so that's it for today. If you like it, subscribe to my channel and like it so that it's safe for you for the further uses of